module 2. And so far, by using sigma y or sigma ultimate and factor of safety, we used to get the stress safely for a static stress. What we used to get is sigma static, so it was safe and reliable. So far we have been using that. But in practice, when you take, say, pulleys, bearings, fasteners, shafts, gears, all the components are subjected to not a constant load, but they are subjected to variable stresses. All the components in practice are subjected to variable stresses. This is very, very important. They are all subjected to variable cycles and loading cycle, and the stress is not steady. Stress is not steady. STEADY. It's not a constant value, but it will keep varying. That's why the components are said to be subjected to variable stresses. So normally failure of these components, most of the machine components, failure would occur because of such repeated stresses or repeated loadings. The failure of the component would occur because of such repeated loads and over a period of time, and even though the stress induced is less than the yield stress value of the material of the component will fail because of repeated loadings. That is, if you take a bearing, for example, it may not fail in 1 day or 1000 cycles. It may fail over a period of time because of repeated loadings. Maybe it will go for some 10 power 5 number of cycles, and then failure may occur. When you take a talk of gears, they may not fail in 2 days or 3 days or in 1 lakh cycles. They may fail after, say, 5 lakh or 6 lakh cycles. So most of the machine components will fail because of such repeated loadings, even though the stress induced is less than the yield stress of the material of the component. Is that okay? Are you there? Are you there? So now let's understand what is fatigue strength or endurance strength. Fatigue strength, or it is also called endurance strength. Denoted by sigma underscore minus 1. So we just discussed that the component will fail because of such repeated loadings. They are subjected to n number of cycles. So the component will fail after several cycles of loading, even though the stress induced in the component is less than yield stress value. Now we should find out, or we should be interested in finding out what is the strength of that particular material. So that is the stress, or the maximum stress, which the component can withstand 10 power 7 or 10 power 8 number of cycles, without failure. That is very, very important. Without failure, right? That is the stress at which the component can withstand 10 power 7 or 10 power 8 number of cycles without failure. That stress is called fatigue stress or endurance stress, denoted by sigma minus 1. Is that okay? So fatigue strength or endurance stress is the stress at which the component can withstand more than 10 power 6 number of cycles. That is million number of cycles, or beyond that. That is 10 power 7 or 10 power 8 number of cycles without failure. Then that stress at which it has endured more than 10 power 6 or 10 power 7 number of cycles Okay, that stress is called endurance stress or fatigue stress. Could you get it now? Could you get it what it is? Yeah? Could you understand what is fatigue strength?
Yes, sir.
Yeah. Please note down. The design stresses which are determined, please note down, the design stresses which are determined, the design stresses which are determined the design stresses which are determined from ultimate or yield point, from ultimate or yield point value, from ultimate or yield point value of the material, by a factor of safety, by a factor of safety, by a factor of safety, gives safe and reliable results, gives safe and reliable stresses, reliable results, gives safe and reliable results, reliable results only for static loads, only for static loads, only for static loads. Okay, next line, next line. Many machine parts like, many machine parts like, many machine parts like spindles, spindles, comma pulleys, spindles, comma pulleys, comma bearings, bearings, comma shafts, comma gears, comma gears, sprockets, sprockets, springs, springs, etc., etc., are subjected to a loading cycle, are subjected to a loading cycle, are subjected to a loading cycle, subjected to loading cycle in which, in which, in which stress is not steady, in which stress is not steady, S-T-E-A-D-Y. Stress is not steady, but continuously varying, but continuously varying, but continuously varying. Full stop, full stop. Next line, next line. The failure in machine parts, the failure in machine parts, the failure in machine parts are generally caused by, are generally caused by, failure in machine parts are generally caused by such repeated loads, such repeated loads, such repeated loads such repeated loads, and stresses will be below the yield point. Such repeated loads, even though the stresses will be, please correct there, even though the stresses will be less than or below the yield point, even though the stresses are less than the yield point. Stresses are less than the yield point. Next, fatigue strength or endurance strength or endurance stress. Fatigue strength or endurance strength or endurance limit stress. You take it as fatigue strength or fatigue stress. Okay? Fatigue stress or endurance stress denoted by sigma underscore minus 1. Note down. It is defined as the maximum stress. It is defined as the maximum stress which a plane specimen can withstand or sustain, which a plane specimen can sustain Yeah, can you hear me now?
Yes, sir.
Till
Yes,
what
sir.
we have taken? Can someone tell me?
It is defined as the maximum stress which a plane specimen can sustain.
For 10 power 7 or 10 power 8 number of cycles without failure. Please take down. Continue. For 10 power 7 or 10 power 7 or 10 power 8 cycles without failure. That is called fatigue stress.
So can you repeat?
Yeah, what is that? Sustain for 10 power 7 to 10 power 8 number of cycles without failure. 10 power 7 or 10 power 8, 10 power 7 to 10 power 8 number of cycles without failure. Without failure. Okay? Next. Take down SN diagram. Take down next SN diagram. Let's understand what this SN diagram is. So now, could you get the clarity that the components are subjected to repeated loading cycles? So the component will fail after several lakhs of cycles of operation. Correct? Correct? And fatigue stress is the stress at which the component can sustain 10 power 7 to 10 power 8 number of cycles without failure. That stress is called what? That stress is called what? Fatigue stress or
Endurance.
endurance stress. Okay, so now let's understand what is SN diagram. S essentially stands for stress and N is number of cycles, right? So what I do is I take several specimens. Okay, I subject those specimens for various number of stresses. So that is, I take S in this direction, that is nothing but sigma. Okay, sigma, again it is in megapascal I will take. So this is 100 megapascal, 200 megapascal, 300 megapascal, 400, 500, 600, 700 megapascal, and maybe I take one more 800 megapascal, right? So on the x-axis, I take this to be 10 power 0, that is nothing but one number of cycle, then 10 power 1, then 10 power 2, 10 power 3, 10 power 4, 10 power 5, 10 power 6, 10 power 7, 10 power 8, and so on. What does this indicate? Number of cycles. Okay, so this indicates number of cycles, that is capital N. Okay, the graph that gives between the S, that is stress versus number of cycles, is called SN diagram. That is the first thing. Now what I do is I take a specimen, subject it to a stress of 800 megapascal. That's a huge stress, right? So the component may withstand only one number of cycle, right? I subject it to, may say, 700 megapascal. So for 700, because 800 is too large, 700 megapascal I take. So it may sustain for one number of cycle only, right? Now this is the point that I am going to get. Now what I do is I take another specimen, subject it to a stress of 600 megapascal. Maybe that will come for 10 number of cycles. 10 to the power 1 is nothing but 10. So what I am going to get is, I get a point here where the specimen which is subjected to 600 megapascals of stresses can sustain 10 cycles. I get a point out there. Correct? Then next, I take another specimen, subject it to 500 megapascals of stress. Maybe it can withstand up to around 10 power 2 number of cycles. so I may get another point out there. Similarly, I subject it to 400 and maybe it can withstand 1000 number of cycles, then 10 power 4 number of cycles at 300 megapascal. Okay, it may withstand 10 power 4 number of cycles at 200 megapascal. It may withstand 10 power 6 number of cycles, and after that it does not fail at all. It keep on going beyond 10 power 6 number of cycles, then it does not fail, so it keeps running on and on and on for 10 power 7 or 10 power 8 number of cycles. So I join these points, at one point it will become a straight line parallel to xy. Is that okay? Parallel to x-axis rather. Okay. So this is what is called as a SN diagram, where it will give us. So what is the fatigue stress of the component now? What is the fatigue stress of the material now? What is the fatigue stress now of the material that I have chosen? It is 200 megapascal, because what is the definition of fatigue stress? It is the stress at which the component can withstand or sustain 10 power 7 to 10 power 8 number of cycles. All right. So at 700 megapascal, it has failed in first cycle itself. At 400 megapascal, it has failed at 1000 number of cycles. At 300 megapascal, it has failed at 10,000 cycles. At 200 megapascal, it has crossed a million number of cycles and keeps going. So this stress at which the component or the material could withstand more than 10 power 6 number of cycles without failure. So this stress is called endurance stress or endurance strength. Endurance stress denoted by sigma minus 1. All right. Could you get it now? Could you get it? Yeah. Could you get it now? Yeah. Anybody? Any doubt in this? Someone please say yes. Then I can go ahead with next. Yeah. Right.
Yes,
we obtain SN diagram. SN diagram is nothing but the diagram between stress and number of cycles. So the SN diagram gives us at what stress, at how many number of cycles a particular material can withstand. It will give us very clear picture of how many number of cycles a particular material can withstand when it is subjected to various types of loads. Or other way around is, if it what stress it can withstand, how many cycles it can withstand when I subject that component to the amount of stress. So it will give that study from SN diagram. Okay, so SN diagram is available for almost all the materials. Okay, yeah, please take down the sketch now. Any doubt, you can ask me. Take down the sketch of SN diagram. If you are finished, then let me know. This is very, very important. Okay, 10 power 6 number of cycles. Whatever that's written, is it clear for you people on the screens?
Yes, sir.
Yeah. Please complete the sketch and let me know. So in the video that we saw yesterday, he was taking loads, okay? Loads then convert it into So by dividing 6 mm diameter specimen we used to take, no? So we will calculate area and then we can get stress over here, right? So whatever the loads and divided by area of cross section will give you stress. So the plot between stress versus number of cycles is called SN diagram. It will give us clear picture as to what material can withstand how many number of cycles against a given stress value. If you have finished noting down the sketch, I'll dictate, please note down. Finished? Chinmay, finished?
1 minute. Sir.
Yeah. This should be a parallel line here. So it can be 200 or it can be 250 or 248 or 328. So depending upon the type of material, so we can find out the endurance stress by preparing specimens of diameter 6 mm as we saw in the video yesterday. Okay.
Yes, sir.
Yeah, note down. The SN diagram indicates the SN diagram indicates the number of cycles. SN diagram indicates the number of cycles required to produce failure at a given stress. So someone tell me at 400 megapascal, what is the number of cycles it can withstand? Is 1000 cycles, like that. Produce failure at a given stress. Full stop. A typical SN diagram is as shown in figure. Full stop. It is plotted on a log paper. Log paper. Next line. Any point on SN curve represents the maximum number of cycles. That a member can withstand without failure at a given stress. Full stop. Thus, the endurance limit stress can be evaluated. Endurance limit stress sigma -1 can be evaluated from SN diagram. Okay. Thus, endurance limit stress sigma -1 can be evaluated from SN diagram. All right, finished up. Next, note down low cycle fatigue. Low cycle fatigue. Low cycle fatigue. So what is this low cycle fatigue is nothing but the fatigue failure which occurs from number of cycles equal to 1 to 1000 cycles, that is number of cycles equal to 10 power 3. So this is called low cycle fatigue. Okay, this is called low cycle fatigue, that is fatigue failure occurring between one number of cycle and 1000 number of cycles is termed as low cycle fatigue. If it is greater than that, then it is termed as high cycle fatigue. Okay. If it is greater than 10 power 3 number of cycles, then it is termed as high cycle fatigue. All right. So please take down low cycle fatigue. Low cycle fatigue. Fatigue failures. Fatigue failures. Fatigue failures from n is equal to 1 to n is equal to 1000. Fatigue failures from n is equal to 1 to n is equal to 1000 cycles, is classified as low cycle fatigue. Is classified as low cycle fatigue. Finished? Next, note down high cycle fatigue. High cycle fatigue. High cycle fatigue. See, fatigue is a very, very important chapter, both from practical point of view also, because in most of the industries you will have a fatigue section. That is all the most of the components, okay, which are subjected to repeated loadings, they will be tested in their R&D labs for fatigue loading. If you go to Ashok Leyland R&D or TVS Group R&D centers and all, you can see that the components are subjected to lakhs of cycles and they keep evaluating. That's a major job in most of the R&Ds, right? Even if you see the spring plates that you see for trucks and buses, so they're all subjected to lakhs of loading cycles. And even if you take brake parts, right? So they're all subjected to 1 lakh, 2 lakh cycles. Then they take out the components and study for any propagation or initiation of any cracks or failures that are occurring. Okay. So fatigue is a very, very important very important testing. Okay, in all R&Ds of automobile or any other industries, right? Where we have got moving parts. Okay. So it is very important to know about fatigue, design for fatigue strength, what is fatigue, what is low cycle fatigue, what is high cycle fatigue. And also when you go for higher studies, again you will have one more advanced machine design where the entire subject itself is about fatigue. Okay, so it's quite important from practical point of view also. So try to have good understanding of fatigue, right? Yeah, where are we now? Where are we?
High cycle fatigue.
High cycle fatigue, yeah. It is concerned with failure corresponding to, it is concerned with failure, it is concerned with failure corresponding to stress cycles, greater than 10 power 3 cycles, greater than 10 power 3 number of cycles. Okay. Next, So what are the factors that would affect the fatigue life of a material or a component, right? That is factors affecting fatigue strength. Please note down factors affecting the endurance stress or fatigue strength or fatigue stress. They are all one and the same. Okay. So strength or stress within elastic limits, we can use stress or strength as same, right? Yeah. Now, the factors which would affect the fatigue stress of a material are majorly the load factor, size is a factor, surface finish of the component, then temperature, then comes the stress concentration. Okay, so these are the 5 factors which would affect fatigue stress of a component, right? One is the load factor, size factor, surface finish factor. If the surface finish is poor, the fatigue stress will come down. If the surface finish is excellent, so the fatigue stress will increase. That's why I think you have done in your metrology lab. I think you have not. Had you conducted the surface finish experiment? Did you conduct a surface finish experiment?
Yes, sir.
Yeah, what is that you found out? Can you remember? RA and Rmax or something like that, correct? Roughness average. Okay, so why we do that is because if the specimen surface finish is excellent, its fatigue stress will increase. So therefore, you have got grinding operation, lapping operation, and so on. Especially in bearings, if you see those steel balls, they are all lap finishing is done, which is superior than grinding, right? So the lap finish will have super finish on the surface. So therefore, the ball bearings fatigue stress will be larger. Okay, got it? So these are the factors that would affect the fatigue stress of a component. Please note down that. Fatigue strength depends on the following factors. Fatigue strength or fatigue stress depends on the following factors. Note down these 5. So within brackets, you just take it as capital A, this is capital B, surface finish as capital C. Finished up? Finished? Finished up? Yeah. Next, stress amplitude and mean stress. Please note down. Stress amplitude and mean stress. Stress amplitude and mean stress, right? So when you plot a graph between variable stresses versus number of cycles, okay, what you are going to get is curve like this. Okay, So this represents sigma minimum, this represents sigma maximum, and this is the mean stress. Okay, are you able to hear me? Are you able to hear me? Yeah?
Yes.
So when you plot a graph between variable stresses and number of cycles, you are going to get minimum stress, maximum stress, and this is the mean stress. So the mean stress is given by, that is sigma mean, that is equal to sigma m is equal to sigma max plus sigma minimum divided by 2 will give you the sigma mean or mean stress. Okay, and the stress amplitude, this is the stress amplitude sigma A. Okay, so sigma A is equal to, that is stress amplitude. Okay, stress amplitude sigma A is given by sigma max minus sigma minimum divided by 2. So this will give you stress amplitude or amplitude of stress. So this is given by equation number 2.16a. Please take out your data handbook. 2.16a is page number, I think 23. Okay, and this is 2.16b in page number 23. I have just shared one data handbook sheets with you. 3 sheets are there. Okay, please check. In one of the page number 23, you have these equations of mean stress and stress amplitude. Is it okay? Are you there? Please take out the data handbook. Whatever that I have given to you, check whether these equation numbers are correct. Someone please let me know. Vipan Singh, please let me know whether you have these equations there. Yeah? Is it there?
Yes, sir.
Is it there?
Yes, sir.
Yeah. Please note down. Please note down this. Please note down this. So remember, we are finding out mean stress and stress amplitude. So we are finding out maximum stress and minimum stress. So while solving the problems, we will have 2 loads. One is a minimum, another will be maximum. So we are going to find out stress minimum with minimum load, stress maximum with the maximum load, find out mean, find out amplitude, then get into Soderberg relation. Okay? Make it fast. If you say you are finished, we'll go to the next. Finished up? Did you finish? Finished writing this?
Yes, sir.
Yeah. Now, note down methods of analysis of variable stresses. Methods of analysis of variable stresses. Take the heading as methods of analysis of variable stresses. Akshat BS, are you there? Akshat? Darshan?
Yes, sir.
What is that you can see here?
Sigma -1 endurance stress.
Sigma -1 endurance stress. What is this?
Stress amplitude.
Stress amplitude. What is this?
So mean stress.
Mean stress. Fine. What is this?
Yield stress.
Fine. This is?
Ultimate stress.
Excellent. Right. Okay. So there are various methods of analyzing variable stresses. The one which takes yield stress as a reference is called Soderberg's criteria, Soderberg's line, or it is called Soderberg's method. Okay. Soderberg's method uses yield stress as the reference. Okay, and next which uses ultimate stress value. This is called Goodman's method. Goodman's method, and this is called Gerber's method. Okay, so there are various methods of analyzing variable stresses. Out of that, 3 are important. Out of those 3, again, 2 are most important. One is Soderberg's method, and another one is Goodman's method. The Soderberg's method takes yield stress as the reference, whereas Goodman's method takes ultimate stress as the reference. But in practice, the method that is used mostly in practice is Soderberg's method, because he uses yield stress as the reference. Is that okay? Is that fine? Please note down that. Soderberg's method, Goodman's method, and Gerber's method. Please note that. You take out your data handbook. It is there, the Soderberg, Gerber, and Goodman's relation. It is there in figure 2.6. Gerber's parabola, Goodman line, and Soderberg line. Okay? You go to figure 2.6, page number 24. Right? So you have got a graph or a figure showing these lines. Okay? So one is Soderberg method, Goodman's method, and Gerber's method. Please note down. The methods for solving problems. The methods for solving problems. The methods for solving problems involving combination of steady and variable stresses. Involving combination of variable and steady stresses, or not one below the other. Soderberg's method, Goodman's method, and Gerber's method. Soderberg's method, Goodman's method, and Gerber's method. Out of the three methods, Soderberg's method finds wider application in practice. Soderberg's method finds a wider application in practice. Soderberg's method finds wider application in practice. Because yield stress is taken as a reference. Because yield stress is taken as the reference. Okay? Is that fine? Is that fine? Yeah.
Yes, sir.
right? Guda Jayant Reddy, are you there?
Also,
Yeah, please read out the definition of fatigue stress. Please read out definition of fatigue stress. Have you written or you are not written? Yeah? You have not written, na? Okay, anyway.
yeah,
Yeah.
also.
Yeah, Ritik Shah, have you written? Kartikeya Avasti, have you noted down? So, I find many not noting down. Okay. What SR means what? Noted or not? Then read out, no? Mic is not working. That's another reason. Prajwal? Prajwal, have you noted down?
Yes, sir.
Please read out definition of fatigue stress. Okay. Mulepati, have you noted down?
Yes, sir.
Please read out definition of fatigue stress or endurance stress.
It's defined as the maximum stress at which a specimen can sustain
Yeah.
for a certain number of cycles.
How many number of cycles? For
For 10 to the power 6 number of cycles.
10 power 7 or 10 power 7 to 10 power 8 is what I gave, no? Okay.
Yeah, mine.
Anyway, all right. Tarun Pachori, please
Yes,
read out
sir.
the definition here clearly. Others, please follow.
It is defined as the maximum stress which a plane specimen can sustain for 10 per 7 or 10 per 8 number of cycles without failure.
Without failure. Okay. Chinmay,
Yes, sir.
please read out first sentence of SN diagram.
The SN diagram indicates the number of cycles required to produce failure at a given stress. A typical SN diagram is shown in the figure.
Okay. You come to the last sentence.
Sir.
It is any point on SN curve.
Any point on SN curve represents the maximum number of cycles that a member can withstand without failure at a
Yeah.
given stress.
That's
Thus,
fine.
the endurance limit stress
Yeah,
can be
that's fine.
evaluated.
That's fine. That's fine. Nadella, are you there? Ashutosh
Yes, sir.
Nadella,
Yes, sir.
please read out what is low cycle fatigue and high cycle fatigue.
Fatigue failure from n is equals to 1 to n is equals to 1000 cycles is classified as low cycle fatigue.
Yeah.
And high cycle fatigue,
Yeah.
it is considered with failure corresponding to failures greater than 10 power 3 cycles.
Stress cycles greater than. So what do you understand? What do you understand by this? Ashutosh? What do you understand by this low cycle fatigue and high cycle fatigue? Briefly, you can tell me.
So 1 minute.
Yeah.
Fatigue failure.
What do you understand by low cycle fatigue and high cycle fatigue?
So the amount of
Yeah.
failure the material can undergo.
Amount of failure, number of cycles. Okay. So that is the component. If it fails below 1000 cycles, it is termed as low
Low
cycle fatigue. Yeah. Right. Okay. Others, you have to please involve. Yeah. Answer your roll call. 1,
Present, sir.
2,
Present, sir.
3, 4,
Present, sir.
5, 6,
Present, sir.
7,
Present, sir.
8,
Present, sir.
9,
Present, sir.
10,
Present, sir.
11,
Present, sir.
12,
Present, sir.
13. Swaroop.
Excuse me, sir. I'm 3. I'm present, sir.
Hey, every time no excuse I say. Every one time is fine. Every time when I call you will not answer. What's your
No, sir, I just
problem?
want to toilet. Sir. I just
Hey,
want to toilet, sir.
since you are telling me, say. Huh?
Sorry, sir.
Yeah, 14. Terishma. 15.
Present, sir.
16. 17.
Present, sir.
18.
Present, sir.
19. Jayant Reddy.
Present, sir.
Yeah, 20.
Present, sir.
Make it fast. Ritik Shah.
Yes, sir.
Your mic is working. When I called you, you did not switch on your mic. Ritik Shah. What
I
is this?
think I was in the washroom at that time.
Hey, what is this? You have to complete everything before 8:30 and then sit there.
I just waited for 1 minute, sir.
Okay.
Sorry, sir.
22,
Present, sir.
23,
Yes, sir.
24, 25, 24,
Present, sir. Present, sir.
25.
24.
Yeah, okay. Vamshi, I have taken. 26, Avasti. Yeah, there, no? Kartikeya Avasti. 27, make it fast. 20, 30, 31, 32, 33,
Present, sir.
34. Niyal
34,
Shetty,
sir.
present. 35,
Present, sir.
Yes, sir.
36,
Yes, sir. 36.
38, 39,
Yes, sir.
40. What, Prajwal? Working?
Yes, sir.
Yes, sir.
Prayag Vasudevan?
Yes, sir.
41, 42,
Yes, sir.
43,
Yes, sir.
44,
Present, sir.
46, 47,
Yes, sir.
48. Sanjay.
Yes, sir. Yes, sir.
49,
Yes, sir.
50,
Yes, sir.
52,
Yes, sir.
53,
Yes, sir.
54. Chaman Saluja. 55.
Yes, sir.
Srinidhi, are you there?
Yes,
Why you are coming now after 30 classes?
sir. That was me, sir, not Srini.
Who is that I say? Me means
You called out my name, sir. Shravan
Chaman Saluja. Why you did not answer?
That was before. I answered that.
56. Siddharth. 57. 58. 59. 60.
Yes, sir.
61. 62.
Yes, sir.
63. 65. 66.
Present, sir.
67.
Yes, sir.
Chaitanya.
Yes, sir.
Madhiwal. Nishant. Ramesh. Shashank.
Yes, sir.
Akshat. Who is there? Shashank.
Yes, sir.
Shashank, are you there? Hey, ಎಲ್ರಿ ಹೋಗ್ತೀರಾ?
Yes, sir.
ಬೇಗ ಬೇಗ ಹೇಳ್ರಿ. 68.
Present, sir.
Patrick Roy.
Present, sir.
Mahima.
Present, sir.
Vatsa. Srivatsan.
Present, sir. Present, sir.
Okay. Suman Xavier. Madan Kumar.
Sir, present, sir.
Manu, Shadab, Ganesh,
Present, sir.
Ganesh, yeah. Vijay Kumar,
Yes, sir.
Rishi, yes.
Yes, sir.
Zair Hussain, Zair. Okay.